because there is this paradoxical kind of thing going on where you have the space industry growing in all manners of ways and technologies, and at the same time, this growth is still kind of pretty constricted. You know, it's very difficult to actually introduce a new stakeholder into a system, especially where you have a lot of technologies or sensitive technologies, or you have to do something that's really complex. So we figured out, you know, hey, let's think of something that's going to make, for example, even the simplest thing that's going to make our space mission easier and cheaper and more accessible. And we figured out that, you know, like make a ground station network, make people join our platform, give us their ground station capacity, they get paid for that. But of course, with this comes the problem: how do we actually verify these people? How do we know that they're going to do what they claim they're going to do? And how do we have some kind of guarantee for what is going to occur? And this is how we basically devised our centralized ground station network platform. It's called Homeport. Basically, we spun it off into a company about 2.5 years ago, 3 years ago, and we've been on this particular journey since then. And our general motto is. General perception of things is that there's a lot of things that need to be fixed. We like fixing problems. We like figuring out what the problem's core is and working it out from there. And in the long run, our vision is to just have infrastructure, you know, just like you have railways, roads, ports, and everything else for conventional infrastructure down here on Earth, to have pretty much the same things in space, and we want to basically be contributing to that through the things that we do. So ground station is an essential component of pretty much every mission. What people see most often is the launcher, you know, the rocket that's basically sending the payload into orbit. They know about satellites and everything else, but there is a component of any space mission that remains kind of obscure to pretty much everyone else. And those are ground stations, because at the end of the day, what does the satellite do? It's up there and gathering data. And the point is that you have to get this data somehow down here on Earth so that you can make use of it. This is especially valid in the case of Earth observation satellites, which downlink very large amounts of data. And the more stations that you have, the more opportunities to get the data through a ground station, the better for you, because you have more windows to basically get what's valuable in this entire construct. So the ground station is essentially an antenna with a hardware stack underneath. It's connected to a network, and the point of the ground station network is, one, to basically communicate with the satellite, so that is send updates, send commands, and so forth. And two, it's to basically receive the valuable data that you can then sell or analyze. And the essence of Homeport is that it basically virtualizes the operations of a ground station. So that means if you have a satellite up there, what you need to do is basically use Homeport to input your technical requirements. Basically, what does the satellite do? What's the orbit? What's the downlink frequency, and everything else. And on the basis of this, you get stations that have been registered by third-party users, matched to your system, and then you can compose a virtual ground segment that basically is going to do the job, is going to get your data for you, instead of doing the expense of setting up your own ground stations, licensing those stations, operating them, taking care of maintenance and everything else, which costs money and time. So this is the essence of Homeport. It basically makes the ground segment a lot simpler and makes it a lot faster to get data. Functions. So let's say you have a space agency or a company that operates a ground station that was built, for example, for a project or a mission that's over. And this ground station is available, but it's not used. It has idle capacity. So what Homeport allows is to, if you're a ground station operator, you can basically register the ground station with the platform. You can sell this idle capacity to anyone who needs it, and it can become part of this virtual ground segment. So this means that essentially it's possible to essentially allow the ground station to be shared to other users, space segment operators, which is good for the ground station operator because they monetize this idle capacity. It's good for the space segment operator because, as already mentioned, they don't need to build a ground station, they just rent it out in a way. Well, there's a growing number of satellites going up in orbit every single year. The consumption of Earth observation data, which is one of the primary benefits and products of space, is also growing year by year. And the idea itself, the concept of a decentralized ground station network came while we were still working within the aerospace engineering team on the satellite. We had a very simple question at hand. So how do we actually get our data more often from the satellite? So we figured one of the approaches is we go around the world, we build our own ground stations, we operate those ground stations, we inflate our budget a lot, and that's how we do it. The other option that we had was to essentially have a way where anybody who has a ground station, wants to contribute to the mission, can basically plug their ground station into a very easy to use web infrastructure, and they basically get a schedule for when the satellite is going to pass above their location. And this is how the data it will be delivered with a pipeline, of course, that basically follows further downstream from the station. And of course, we realize that this is something that can solve a lot of issues to a lot of other people. And we did a little bit of digging. We discovered that there are some platforms available. There are some solutions out there, but we wanted to make it very, very simple to integrate the stations into a platform, very simple to schedule this and just make it, essentially make the ground segment something that you can just dial up on an API or through a very simple user interface, monetize it, and basically make the whole operation much simpler. Of course, the short-term goal is to develop and test the architecture because there are different approaches to solve each problem, of course. And essentially, one of the things that we did right after we validated the need for this product is to pick the best technological approach to solve this, something that's going to be sustainable, something that's going to be working in the long run, pick the necessary technology stack. So that was the ultimate, very short-term thing that we embarked on. Of course, the next step is to basically acquire the ground station capacity. And the third-party station approach is one of the two existing approaches. In fact, there is also the approach where you can own your own ground station network. And essentially you can provide a baseline capacity of stations that you own, and you can essentially plug them in, and it's all up to you how the station operates. So you essentially embark on taking this cost. So the midterm goal of Homeport is essentially to acquire significant third-party station capability so that we can rapidly deploy an operational capacity of stations. And the long-term goal is to begin securing this baseline capacity. So this means that in the long run, we envision having both types of offering. One of them is an offering based on third-party stations, and the other one is a more predictable, which is more long-run type of offering baseline capability with in-house stations, which we plan to start deploying sometime next year. Yeah, so there are two types of customers. Of course, you have starting companies, you have small space agencies, particularly many small new space agencies that have been recently formed and are very largely focused on practical benefits of space, such as Earth observation data. So these are natural clients that would like to keep their costs minimal, especially if they're working within a government budget. And this is a solution that for them would be very convenient to essentially extract the most of what they're launching up there, while at the same time not taking care of building their own infrastructure and having a very large network. The other type of customer is, of course, companies that operate constellations of satellites and quickly want to deploy this capability. For which we already have requests in this regard. So this is something that's interesting, presents a little bit more of a challenge because over there, its operations include a lot of satellite, dozens of different units up in space, which is a little bit more challenging. And of course, those companies are very eager on pushing the data and providing it as quickly as possible to all the users that may find. Because at the end of the day, Earth observation data has a number of uses, a number of potential customers' use cases, and the point is to actually get this data across and have consumption for this data. And in the long run, one of the things that we also emphasize is precisely this: to bridge the ground station network and the data environment where the data is essentially received, bridge it to consumption points and marketplaces, so that this makes it possible to deliver the data instantly and monetize it as quickly as possible. Well, there are a number of challenges, particularly in the ground segment. One of them is, of course, the technological challenge. Ground stations are very, very complex systems. And unlike, let's say, CubeSats, there's still a long way to go until everything is standardized and everything is pretty much made the same. If you can have one ground station that has a specific hardware stack, then you have another one which is completely different in terms of what it operates and how it operates it. You have even older legacy systems. There's a lot of challenges in putting all these disparate systems together within the same framework and presenting them as a standardized offering when it comes to third-party stations. This is why sometimes in certain situations the unified approach where you own the ground stations is better. So that the technology is one of the main challenges, but the good thing is that the trend is towards virtualization. So that means that more and more of the hardware that sits underneath the antenna is becoming basically software that you run on a cloud, which makes it very possible, makes it much easier to begin standardizing these systems. The other challenge is, of course, that the ground segment is actually not that familiar. It's not, let's say, as exciting as building a launcher or a satellite. So it's a little bit more difficult to, explain. There's a little bit of education going on when you have to say, our business model is based on these types of ground station offerings. So this is kind of challenging in terms of creating a narrative that's, like, wow. But at the end of the day, it's a very significant issue that as the number of satellite keeps growing, as the data consumption keeps growing, it's going to become more and more relevant and more required to have such solutions. There's a lot of disparity between systems because at the end of the day, especially with legacy systems that have been built for specific missions, especially those operated by space agencies, the station has been built with a specific satellite or mission in mind. Then you have to do a little bit of tweaking to get it functioning for another type of data delivery pipeline. So there are plenty of challenges in basically integrating these systems. But as already mentioned, the trend is positive, and there is a move towards simplifying what's going on under the antenna, let's say. Yeah, I think, like I said, one of the issues is essentially the narrative and basically showing that this is something required. Because the ground station is, as already mentioned in the beginning, it's something that's a little bit obscure. So once it comes down to, let's say, presenting the project, the technology, the solution that is being provided, it's a little bit more difficult to create a narrative, let's say, for investment or for something that's involved in essentially presenting how this works and how it solves the problem. So I think this has been the most challenging thing, but it's something that we've been essentially formulated in a way that's very digestible and very, very simple to present. Difficult thing, because in terms of technology, of course, there's plenty of challenges that engineers can at the end of the day they can work on. But in terms of building up a proper narrative, this has been a little bit, let's say, more challenging. I think it's a lot easier, mostly because essentially the ground segment is becoming more visible. There have been solutions that are out there, let's say by major cloud providers, that essentially give this segment a little bit of visibility, because this has been something that's been fairly niche. But over the past couple of years, there's been growth in the ground segment. There's been growth in realizing the need for how this data is being delivered. So there's been a positive trend in this regard, and we've done a pretty good job at simplifying this pretty complex set of issues that exist around the ground segment. So I would say there is an improvement, especially in awareness and knowing that this is a critical segment. So on the space segment side, these are pretty much within the framework and within the categories that I mentioned. These are space agencies that require additional ground segment capacity, especially those that already operate Earth observation satellites and want to maximize the output of the satellite without essentially having to deploy new ground station capabilities. Constellation operators, Earth observation constellation operators, IoT constellation operators, and of course single satellite operators that are looking for capabilities that, let's say, cannot be acquired easily out there. Specifically, let's say certain regions that may not have ground station capabilities. Well, I would say plenty of insights about the industry itself, but one of the major things is, of course, specifically in ground segment capacity, is to one of the lessons that we've learned is to focus on rapid deployment, rapid capability expansion, which is precisely why we've been taking the third-party station approach, because it's a little bit faster to basically set up capability in this way. So one of the things is to basically set the foot in the door and start offering capabilities. And this has pretty much defined the initial approach that we have for Homeport, and the way that we essentially provide the capability that we have right now. Of course, in the long run, like I already mentioned, we're planning to have a more flexible approach as to what kind of capacity is being offered. But at the end of the day, I think this would be the most important lesson. Just deploy operational capability as quickly as possible, start getting traction, and I think this has been the biggest lesson so far. Well, I've learned that sometimes when things don't look particularly good in certain regards, the point is to just like keep pushing and keep persevering, because there's something that can be extracted out of every situation. I know it sounds a little bit like something that a lot of people say, but I've seen this being confirmed firsthand. There's been a lot of situations in which you think there is no way to progress on a specific issue or on a specific solution. And even if at the moment it does look like this, at the end of the day, like maybe a day later or a month later, you can actually find some utility in this situation that you had previously, and you can basically move on and you just have to keep. But to reach that conclusion, you just have to keep on going and pushing forward.